Hello, my name is Dylan Jackson, candidate number 1755, and this is my code walkthrough video for my computer science NEA technical solution, which is a game of Othello with Minimax implementation for single player game mode. So we're going to have a look at this first. We'll look through the decorations class. This is just a whole load of methods and variables that apply to all of the different menu screens of the game, so be that the main game loop or the main menu or the instructions menu or the end menu, anything that is shared by more than one will be in decorations. For example, drawing text, or just updating, flipping the display, assets, which are specifically just the pieces which are loaded from PNG files, and then global events, which are anything to quit the game, essentially. So just, if the escape key's pressed, the game will stop. If the window is shut, classic, it closes the game. So that's what that does. That's about it for the decorations class. Not much going on with it. Just things that are inherited by these other menus. Then game. This is the. Actually, we'll go in order of appearance, which means we'll next go to menu. This is the main menu loop, the main menu function, sorry, class. So this is the init statement. Then load buttons, just all of the buttons that are loaded for this main menu, which are all of these, as you can see. Then this one's for drawing those buttons. Then what each of the buttons does. And then in the initialize game, this is just to, when start is selected, this gets called. So if this receives instructions, it's that. If it receives anything else, then it initializes game, because it means the only things that return are start and the instructions button, as you can see, and this returns instructions specifically. So that's what that does. Then this is just the main menu loop, as well as some Pygame mouse events for clicking on buttons. Then this is just the starting. When the game opens, the menu is loaded first. So back up top, we've got the game class. This is for the game loop. This to initialize everything. The load game decor, that is buttons again, but for the main game loop this time. So if we open it up, we'll select normal one player, for example. It loads these three buttons. So save button, save JSON, and abandon. So that's what this is. Then get delta time, that's just to get delta time. And then draw game decor, same, it's similar to load game decor, except this time it's drawing all of those buttons and also these different parts of the screen. So it draws the turn indicator border, which is this black / white box here. Sorry, the turn indicator border. Yeah, then the text border, which is it's this little green thing back here, and then the board box, which is this black one. So that's that, and then there's the text that just says what turn it is. Then draw game buttons, so it just draws the buttons that have been established in load game decor. Draw board, that's specifically for the pattern, as well as establishing what the text is. So if it's a black player, white player's turn title, which is then drawn in draw game decor, it's turn title. So that's that, and then this is the bits for drawing the grid, and also for drawing the pieces onto said grid. Then that is to essentially just make sure that it draws it again. It draws the current state. this does all the drawing. This does all the board, sorry, and then this does the players. This drops the little counters. Then assign move. This one, it just is essentially the loop for when something is clicked. This is called. So has it already run Minimax? No. Goes through, gets the available moves there, which is in gem moves, which is in here. And tile choice is link move. Link move is in the also in current state, isn't it? Yeah. So that's what that does. And then it also does just the updating of board once it gets the correct outflank tiles. Makes the move and then just resets itself so that it can be run again. Then get game button events. This is the same as in the main menu class. This is just gets the events of the different buttons. Then get events. This is for specific mouse and also mouse position, and also just if Minimax is running or not. This is then what is used to activate the Minimax. Then this is use Minimax, which is what's called in here. When this gets called, it starts the Minimax running, so it will just it just runs the Minimax once. And then this is the main game loop here. So all of your while it's running, all of these events, and if at the end of the game stops running and displays the end screen. Then instructions. This is specifically just a small little class for oh, it's still running somewhere. This is a class for this particular page here. Just displays how to play. So not a whole lot going on here. Just initializes the the menu, then just loads the one button, which is the return to main menu button, and then draws all of the text here. Get button events, which is just for the one button. And then this is the instructions main menu loop, which is just essentially all the same things as the other two, just without all of the specific bits that are required. So this is just get button events. Yeah, there's nothing to do with the mouse in this one. Then we've got the end screen, which is the screen that displays when the game ends. So if I demonstrate that, this is the end screen. This displays so I just loaded a board that is an end state. So this is just what gets displayed. This it takes what the outcome is, which is who won, and then it defines the winner as self. The outcome is just either B or a lowercase b or a lowercase w. So this makes it lowercase, and if it's this, then it makes it the winner is black, and if this, then it assigns the color as white. That's just for the color of the text, because the color of the text changes to match the winner. Load buttons, that's the same, just loads the return button. Draw end game screen, that's just draw some text and draw the button. Get button events, just for the one button. And then the main loop, very, very small, not a lot going on again. Then the button class, this is just for all the buttons that I use. So just draws, this is how buttons draw onto the screen. And then this bit about being active is only really applicable to the start button, which activates when a difficulty is selected. So if it's not been selected, then it goes dark green, as like here. And then if it is selected, it goes grey with a border of black. So that if I click on that, now it's active. Next, this one down here, define clicked, is just getting the mouse position, and if the mouse position is pressed, then returning the coordinates. Returning has it been clicked, as in the button. So next we want to move over to current state. This is the file responsible for all of the essentially like non-GUI elements, so all of the main game bits aside from Minimax, which is in here. So the current state class, this is responsible for the vast majority of stuff that happens in this file. So this is all board setup and game setup. Then, oops, let's close that one. Then link move, this takes in the mouse coordinate, so mouse pos from in get events in the game class. This then converts that into, it translates that into a tile on the screen so that it knows which tile I'm clicking and the coordinates of the mouse in relation to what tile it is. If I'm clicking a coordinate between here and here, it knows that this is tile 0, 0, and so on. As you can see here, it's essentially just if it augments the maximum minimum column and row each time, and the minimum column. The width of the square is 75, so minimum column plus 75 is the minimum column being the edge of the square essentially, and maximum column being the other side. So this side here would be minimum, this side will be maximum for this one. That's all that is. Next, update board, that's just goes through each column and makes sure that the tile that has been selected is the one that's been clicked. So when you click on a tile, it will, as long as it's legal, this will get called and it will then assign the piece to the grid. Current turn, it just returns. This is just the turn. Move piece just gets the tile and row column, the column and row for the tile, and then assigns that to piece moved, and then adds that to a move log. Then the next turn just assigns if it's currently B, now it's now it's white, and if it's black, then now if it's white, then now it's black, and it also assigns the opponent. In the end calculation, then it starts off just by saying something went wrong in case something does, but that's just a placeholder because nothing. I've not come across any issues where that does end up displaying. This just assign for every single column and tile on the board, goes through them. If at any point it sees a blank, then it's not the end of the game, and then it also looks for if the board somehow is loaded empty, it will also end the game there because you can't place anywhere. That's just a little error prevention. And the other one, and then of course if the game ends, then this is printed. Next, the get file name. This is just receives an input, checks it with forbidden characters, and if it doesn't contain any forbidden characters, then returns it. And if not, it says that's not a valid file name, please, Then save game _JSON, that's specifically the button that is, this is what happens when the button of the same name is clicked during the game. It gets a file name from file name. It then gets the ending of the file name. If the ending of the file name is already .json, that's what the slice there is, then it doesn't append .json to it. If not, then it does. This just allows you to, what if you want to save the game, it allows you to just type in your title without the having to need the extension, because then it saves perfectly as, you know, your file plus the .json. So hello.json just stops there being, it lowers the risk of there being any erroneous files. So then it, of course, it opens the file and it dumps all the data onto the file and closes it. So then the save game.txt, it works a similar way, checks the ending if it's .text, then it doesn't do anything, if not adds .text to it. And then this one is a little bit more complicated because it requires manually going through and printing each element of the board rather than just dumping the data. But this is just for doing the board, and then does this little loop here to add the other bits, which is turn and mode. So then the files end up looking like something like this, with the board here, then the current turn, and then the game mode. So that's what that one is. Then load game is very similar, just does the opposite. Gets the file name ends in .text, then it will, it tries this, if it ends in text, it will then open the file name and read the lines, and then do all this for just managing text files. And then if it's JSON, then it just gets the data. It's much more simple. I mean, these are just print statements for testing. And there we go. Now move on to the getLegal class. This is a class that is only does things that require it to know if it's a legal move. So it's generate legal moves and get legal flanks. So nothing. It doesn't need to initialize anything because it's just these two. Generate moves just goes through individually. I do talk about it in the testing video, but I'll talk about it again. It uses get flanks. It goes through every single tile of the board, inputs the coordinates of that tile, like the tile coordinates rather than the mouse coordinates, inputs the tile coordinates of that tile into get flanks. If anything gets returned, then it's like, yep, fantastic, that must be a legal move because it has outflanks, and then returns what those legal moves are in a list. And then get flanks works a bit differently. When you click initially, this gets called, or during gen moves as well. It takes a particular tile coordinate, and then using each of these directions, adds each of these direction coordinates to it. If the next tile it comes across is not blank and is not immediately the turn color again. So if it comes across the next piece, which is an opponent, it will then add that tile coordinate to a list of potential outflanked pieces. It will then carry on in the same direction until it reaches a piece of its own color. At that point, it will then accept the list of opponent pieces as correct flanks and will return them. So, and then the move class is just to define what moves are. So self tile column is equal to the n square, and n square 1 piece moved is equal to that. So that is just very, very simple, that one. Next, player. This is the minimax, the file that contains all the minimax information. So the first function is the minimax function. This one takes in, it takes in the board state, the current one, then goes all the way through till it reaches the correct depth. So when depth is 0, then it works its way back up, returning all of these returning all of the values for each of the board states. And then this is for the minimizing, so it alternates between maximizing and minimizing for each node of the tree. Next, try move. This is just it takes a copy of the board, applies the move to it that it thinks is a good move, then returns. They just returns what that state is. And these are the little heuristics. So mobility heuristic, this defines how many moves either player has, and then if the AI has more moves than the player, then it calculates, it calculates anyway, it returns what the value is. This is then used in evaluate later on. If it's a higher value, it means that the AI has more moves, therefore it's a better move. Then corner weights, this one just is about the weighting of each corner. So each corner in the game is super valuable on the board because it can't be outflanked if you have one of your pieces on that corner. Therefore, it calculates, does this particular state contain any pieces on corners? If so, which ones are they, and what is the value because of that? So if it's the turn, then a value is added. If it's not the turn, then the value is taken away. And then corner adjacents, these are the pieces around the corners. So essentially the way this works is if in the game your opponent is on the pieces around the corners, it gives you a much higher chance of getting the corners. So that means that putting one of your pieces on a corner adjacent piece is not a good move. So what this does is, there's a little dictionary here of all of the adjacent pieces. So for this corner, which is top left, it's all of these ones, and then for top right, it's all of these, and so on. For each of the corners, which are stored in it up here, for each of those, if it finds that one of its own pieces ends up in a corner on that particular state, then value is taken away because the corner adjacent pieces, if it ends up in a corner adjacent piece, the value is taken away because it doesn't want to be there. And of course, if the value adjacent pieces are empty or occupied by or not occupied by your piece, so the opponent's piece, then value is added to that state. Then this is the one for terminal state. So it basically, if no other moves are available from this point, so it's the end of a game, this state just calculates that. So it assumes game ends true. Has a look, gem moves. If it has any moves from the turn being from its position being the player to go, then it's not the end of the game. And the same if the opponent has any possible moves, it returns false. So for evaluate, it takes all of the different weights of for the heuristics, and then basically counts up all the pieces on the board that are yours, that are the AIs, and all of the pieces that are not the AIs. Then assigns value to whatever that number is. Corner value it gets from the corner weights. Mobility heuristic value it gets from the mobility heuristic, and the adjacents value it gets from the corner adjacents function. Then the total value is calculated by adding up all of the pieces together once each of them has been multiplied by their weight, then gets a total value, which it then returns. And then choose move, this is the one that uses all of that. It gets all the moves here for gem moves, all the available moves for a particular state. Then it, for each of those moves, it tries it, and then gets the minimax value for that. If the value is better than the best value, that becomes the best value. Pretty straightforward. And then get opponents is just if the turn is equal to the current turn, then it returns the opponent. Otherwise, it returns the turn. And then state, this is just to define what a state is, which is just it has board, turn, and opponent. So that was my code walkthrough video. This was not my testing. This was just a video to demonstrate and talk about what each of the parts of my code does. So thank you very much for watching.